Hello! As you know, statistical analysis is one of the important parts of data analysis process. Let's expand our knowledge of different functions in Excel, and in this video you will learn several statistical functions which are used very often during data analysis. Most frequently used statistical functions are max for calculations of the maximum value in a set, min for calculations of the minimum value in a set, average for calculation of the arithmetic mean of values, median for calculation of the middle value in a set, mode for calculation of the most frequently occurring value in a set, var for calculations of the variance of a set, standard deviation for calculation of the standard deviation of a set, and correlation for calculation of the coefficient of relationship between two sets. For example, let's calculate with statistical functions for the cost of product. Let's at first freeze our top row. If you don't know how to do this, go to View, Freeze Panes, Freeze. Now you will always see the top part of the sheet. Let's calculate the maximum. Is equal to max, the range of values, close the bracket, enter. We see that the maximum value of cost of products is $3,000. Now let's calculate the minimum. Is equal to min, again, the range. Here we get $50. The average value, which is the arithmetic mean at the same time, is equal to average for this range, $125. In statistics, there are three statistical averages for getting a central value of a dataset. Mean, which we calculated by average function, also median, and mode. When there are extreme values, or in statistics language outliers in a dataset, arithmetic mean or average is not a good enough representation of the data anymore. That is, when median comes into play. Median is the middle value of a dataset. Let's calculate. Is equal to median for the same range, $55. We see that the median is close to the average. It means that we have a smooth set of costs without outliers. Now, for more illustrative showing, let's change one cost of product and insert, for example here, $1 billion. Only for example. Enter. You see that our average was changed, but our median wasn't. That is why, in such cases, the median is a better central value for the whole dataset than the arithmetic mean. Let's undo the last change. The third famous average type is mode. The definition is simple. Mode is the value that occurs most often in a set. In theory, it's useful when the numerical values in your dataset are used as categorical values. Let's calculate the mode. Is equal to mode, this one, for this range. We see that for our data, median and mode are the same. Let's change the format. Now, the next two measures variance, and standard deviation are for showing the average distance of the values in your set from the average value of the set. Let's calculate the variance by var p function. Var p. Let's select this one because we are calculating the measures for our whole data, not for the specific sample. Fill the range. We can calculate this measure also by hand. From each value in the set, subtract average value of the set, fix it, close the bracket, and because average can be less and more than this value, this specific value, to avoid negative values, add square. Now, for this column, let's calculate the average. Let's copy this formula here. And we got the same value as here. I did these calculation steps to show you that variance of a set as value has larger dimension than values in initial dataset, because here we have the square of a values. That is why we should calculate the square root of the variance. Let's calculate. Square root of this value. And so we got the standard deviation of the cost of product. Or the same measure we can calculate by standard deviation function. Let's write. Standard deviation p, again, for whole population. Fill the range, enter, and we got the same result at once. The greater the standard deviation, the greater the distance of values in a set from a mean. In addition, let's calculate the correlation between cost of product, for example, and revenue. We will do it by correl function. Fill the first range of values, the second for revenue, close the bracket, and press enter. Correlation shows the coefficient of relationship between these two variables. Correlation varies between -1 and 1. Closer the coefficient to the -1 or 1, stronger the relationship between variables. Closer to the 0, weaker the relationship. Here we see that there is very strong correlation, in that case positive relationship between the cost of product and revenue. We will explore more about relationship during the visualization section when we will learn scatter plot chart. Now you know how to calculate the statistical measures of data by which you can describe your data. That is why these measures in statistics are called descriptive. These functions are very useful in data analysis. Keep practicing. Thank you for watching.